Good morning, students. Today we'll study about how ICs are packaged. That is also called encapsulation. So the packaging requirements are they have to be having very low parasitics. That means unwanted capacitors and resistors of these packing materials should be very low, and they should be very strong. Mechanically, the strength should be high. They should not break easily. So they should give a reliable and robust operation. And uh, thermally, they should be withstanding high temperatures. And economically, it should be viable. That means it should be very cheap. So if we see the way in which the ICs are packed, the external packing material will be covering the chip, and the connection from the contacts will be connected to the leads in the form of wires in wire bonding. So here only the periphery of the chip is available for IO connections, and it should the packaging should provide cooling from back of the chip, and it also should have very less inductance. So the wire bonding is shown in the uh, photograph here, and you can see here it is going in the form of a golf stick here in a very thin wire form, and this is the external lead. And here the on the surface these are called pads, and this is the entire die, and this is the substrate over which the um, chip is placed. So if you other than wire bonding, how the chip can be connected to the package in the form of flip chip, where the chip is placed over the package in, and the pins now they are in the form of balls here. So you can see here this is a flip chip type of bonding, wherein the connections of the chip to the substrate is in the form of balls. So in the side view, you can see here the photograph of which is shown here, and this gives automatic alignment, and it's a one-step process, and thermal matching between the chip and the substrate is required. The chip and the substrate is required, and it offers very low inductance. So all this what you see are the, connections to the chip in the form of balls. So here in the form of polymer film also, the connections can be established with imprint of wiring pattern done on the polymer film. So in the side view, you can see here, if this is the chip, this is the substrate over which the chip is located, and they are connected to the film with the help of solder bumps. So this type of bonding is tape automated bonding. And we see here different packages, hole mount packages, where the IC is going to be fixed onto the board through the holes where the lead pins are stuck through the holes to the board, and they are smoldered on the other end. So you can see here, this is dual inline package, and how pins are provided on either side. Dual inline means on either side you will be providing the pins. So there are multiple packaging of through hole mount packages. So if you see, plastic dual line package is called P-dip, molded dual inline package is called M-dip, and again there are multiple varieties based on how thick the package is: standard, skinny, shrink, and zigzag line package, where the pins come out perpendicularly to the circuit board, and CERDIP package, where the body is molded with ceramics and the sealing material used in this is glass. So in pin grid array, the body of the package is made of ceramics and the pins are arranged vertically from the body and can be placed on a grid. So here, in this case, you have surface mount packaging, wherein the chips are placed and the pins are placed in such a way that it comes out from the surface. So there are multiple varieties in this. If you consider small outline L lead package, it has gull wing type leads that come out on either direction in the form of L, and they are mounted directly on the board. And if you observe quad flat L lead package QFP, in this case also the leads are drawn out in all four directions and they are provided with heat sink. In ball grid array, they have solder balls in the form of arrays placed on the back surface of the PCBs. And in fine pitch LAN grid array, the solder LAN arrays are on the back surface of PCBs. So wafer level chip package are those which are made of wafer. The package material is made from the wafer. So if you compare these two types, that is through hole type and surface mount devices, through hole type has a bigger size and surface mount packages are smaller. The component density in surface mounting is higher compared to the other one, and assembling errors are automatically corrected by molten solders in surface mounting, but this is not so in case of through hole package. And in case of electromagnetic compatibility, the ability of the electronic devices and components to work correctly even in the presence of other devices that emit electromagnetic waves. This ability is more in case of surface mounting when compared to through hole mounting. The cost production, that is the money involved in the production of through hole package, is more when compared to surface mount devices. So surface mount device packaging is preferred. So there may be faults when packaging is provided also, and in case of small ball chip scale package, you can see the contact which has to be like this is missing here. So this establishes open circuit here between this component and the lead connection. And here also there is a gap when a connection has to be present between this layer and this layer in the form of a ball. There is a gap here which can lead to fault. So that's about packaging.